Okay, so welcome back everyone. We will continue with our tutorial for today. Last time we learned about the idea of Bernoulli equation and we learned about the calculation of pitot-static tube. However, for that particular study, the pitot-static tube is based on the idea of pitot-static tube in terms of experiment, which means we have rho GH. For this one, we change the calculation for today and we focus on a pitot-static tube connected with a manometer. Alright, so a pitot-static tube connected to a manometer is tapped to a pipe as shown in figure Q1. The specific gravity of glycerin flowing inside the pipe, which is here. I believe the flow will be from left to right. And then rho for glycerin should equal to 1.3 or 1300 kg per meter cube, and then the density here for oil. Alright, so the density of oil should equal to 850 kg per meter cube. Right, so if the diameter of the inlet section is 100 millimeter, so here diameter is equal to 0.1 meter. Determine the pressure difference between point 1 and point 2, P1 minus P2, and the volume flow rate Q of oil inside the pipe. Okay, so we have two questions over here. Number one, the P1 minus P2 pressure difference. Number two is the volume flow rate Q of oil inside the pipe. Okay, if you see a question that based on the idea of pitot-static tube connected to manometer, this part of the question should be on Bernoulli equation. This part of the equation should be on manometer. Okay, and remember the purpose of a manometer is to find delta P or the pressure difference. Okay, to start off, so what should we do? First, based on the information that you have, okay, so we go on and do the Bernoulli equation in terms of pressure because it is based on pitot-static tube. So what we have is P1 plus rho 1 G Z1 plus rho V1 square over 2 equals to P2 plus rho G Z2 plus rho V2 square over 2. And remember, if you have the same elevation over here, elevation at point 1 and point 2 will be cancelled out. And remember, if you see a pitot tube, alright, so how do you know this is pitot tube or not? You can check. It is L-shaped. When it is L-shaped like this is a pitot tube. Without L-shape, it's just a static tube, or we call it as piezometer. Alright, and here we have an opening for the pitot tube. So this is where we get the V stagnation equals to 0. So each time you have a pitot tube, the end of the L shape where you have an opening, this point over here, the V will equal to 0 because this is V stagnation. So this point, it is equal to 0. So you have an equation of P1 plus rho V1 square over 2 equals to P2. So if we rearrange the equation, V1 should equal to P2 minus P1 and then multiply by 2 and then divided by rho, and then you have the square root of it. Okay, so to find out P2 minus P1, we need to use the manometer study. Okay, so to do the manometer calculation, we can do it this way. Alright, so this is for Bernoulli equation. So this is for manometer equation. Alright, for manometer, the first thing that we know is we have 2 points. Okay, that's good. We have height over here, 14 cm. Check on how many layers we have. We have 1, 2, and 3 layers of liquid. Okay. The distance from 1 over here to this point is unavailable, but we can just put it as A or X or Y. It's just there in order for us to do the equation. And then you can discover that after that we can cancel out because of the same liquid here and here. Alright, so we do the calculation for manometer. P2 equals to P1, and then remember because this is higher and this is lower, we are going from left to right. It's plus rho glycerin, G, and then the distance here A plus 14 centimeter, so A plus 0.14. Okay, and then minus rho oil, G 0.14, and then minus rho G glycerin, and then G A. Alright, you can see from here this G and A is positive here, this one is negative, so this can be cancelled out because both of them are for glycerin. So you will get P2 minus P1 is equal to rho G times 0.14 multiply rho oil, here, times 0.14. So it is equal to rho of glycerin is 1300, 9.81, 0.14 minus rho of oil, which is 850 times 9.81 times 0.14. So the answer for P2 minus P1 is equal to okay, so the answer will be 618.03 Pascal. Okay, so P2 minus P1 is 618.03 Pascal. So the answer for P1 minus P2, it should be the other way around. We change the sign of it, becomes negative 618.03 Pascal. Okay, and then the second question asks us the volume flow rate Q of oil inside the pipe. So how to do that? We have to use this equation here. So we use another page. Alright, for that question, what we need to do is we rewrite it again here. Okay, so we replace P2 minus P1 with this number, 618.03. So 618.03 multiplied by 2 divided by the density. So what density are we going for? This density over here, because this is on Bernoulli equation, it's on the piping system or the nozzle over here. Alright, so the rho over here should be rho of glycerin, which is 1300, and then the square root of it. So you will get V1 equals to so 0.975 meter per second. Alright, to find out what is the volume flow rate, should be A1 V1 should equal to pi. This is 100 millimeter, 0.1 square over 4 multiplied by 0.975. So Q should equal to okay, 7.658 times 10 to the power of negative 3 meter cube per second. So are we done yet? Not yet, because we need it in liter per minute. So Q equals to 7.658 times 10 to the power of negative 3 meter cube per second multiplied by 1000 liter divided by 1 meter cube. So Q should be equal to 7.65 liter per second. So that will be the answer. Okay, so that covers the study of pitot-static tube. Alright, the second question is on Venturi meter, where we have a combination of Venturi tube. Okay, so the study over here is on Bernoulli equation, and then we have a combination with manometer. Once again, the function of manometer is to find delta P. Okay, so water flows through a pipe at a rate of 170 liter per second. The pressure difference between the two pipe sections is measured by a mercury manometer SGHG 13.6 here. Okay, determine the deflection H. So the question asks us what is H over here. Alright, so once again, this is a question combination of Bernoulli equation and manometer. So what do we do here? We just put a point here and a point here. This is I, DI, and also O. Alright, so in between I and O, the elevation should be the same, and the distance from this point to this point, we can put it as A also. Okay, so to do the calculation on this, first check we have diameter here and diameter here. So we need it in terms of meter. So DI should be equal to 0.18 meter. The outlet should be 0.1 meter. Okay, so usually if you have to do this calculation and this involves Bernoulli equation, we need to find out the velocity. This is not a pitot tube. Why? We don't have any L-shaped tube here. So this is just a basic manometer and Bernoulli equation question. So to do this, first we find out what is the area of I, which is equal to pi 0.18 square over 4. So this should equal to okay, 0.02545 meter square, and then area for point O should be equal to pi 0.1 square over 4. So it will be 7.854 times 10 to the power of negative 3 meter square. Okay, so we want to find out what is the velocity at point I. So Q is equal to 170 liter per second. We change it into meter cube per second. So times 1 meter cube, 1000 liter. So Q is equal to 170 0.17 meter cube per second. Alright, so now we can find out what is the velocity at point I. So Q is equal to AIVI. So VI is equal to Q over AI. So equals to 0.17 divided by AI 0.02545. So VI is equal to 6.68 meter per second. Okay, and then we get this for VI, and then for V outlet should equal to Q over A outlet, which is 0.17 divided by 7.854 times 10 to the power of negative 3. So V outlet should equal to 12 21.65 meter per second. Alright. So now we can do the Bernoulli equation, and since we want to get the answer for H over here, so we need to get it in terms of P1 minus P2 so that we can compare with manometer. Alright, so the connection between these two is delta P. Okay, so to calculate P1 over rho g, we use a normal Bernoulli equation. K plus Z2 plus V2 square over 2G, and then I and O, sorry, it's I and O. I'm used to 1 and 2, so I and O. Right, so if you can see from here, the elevation is the same, so Zi and Zo is cancelled out. Okay, and then we rearrange it to be Pi minus Po is equal to Vo square minus Vi square divided by 2G, and then multiply by rho g. So it should be equal to 21.65 square minus 6.68 square divided by 2 times 9.81. Okay, so the density for this question is water. It's not mentioned there, so it's 1000 times 9.81. So Pi minus Po is equal to Pi minus Po should be 212,050.05 Pascal. Okay, so we will use this number in the next slide. So we put it here. Pi minus P outlet is equal to 212,050.05 Pascal. Okay, so next we will use the manometer and we'll try to search for H over here. Once again, I draw it back this way. So this is I, this is outlet. So the distance here, we put it as A. So now we can do the calculation on manometer. So for manometer, alright, PO is equal to Pi plus rho water G A plus H, and then minus rho mercury G H, and then minus rho water G A. So this is positive A, this is negative A, so we cancel out. So P outlet minus P inlet is equal to rho WGH minus rho HGGH. So equals to GH. I factorize it, rho W minus rho HG. So it is equal to 9.81 multiplied by H multiplied by 1000 minus 13,600. So the answer will be negative 123,606H. That will be the answer for PO minus PI for manometer. If you want to use the Pi minus Po from the Bernoulli equation to compare with this, we need to change it back. Pi minus Po will be the other sign than negative over here, so it will be positive. 123,606H. Okay, if we compare it with the one from Bernoulli equation, so it is equal to 212,050.05. So H is equal to 1.716 meter. So that will be the answer for this question. Okay, so once again, Venturi meter is a study of Venturi tube connected with a manometer. So the answer for this question will be H, 1.716 meter. So how do you do this? We combine the study of Venturi tube in Bernoulli equation. We find Pi minus Po here. Then we try to find Pi minus Po for manometer. Then we compare both of them together. Okay, so that's the answer for it. Okay, so this is another question on Venturi meter. It is almost the same as what we have for the study of Venturi meter in the slides from our class. Okay, so figure question 3b shows water is flowing upward at a rate of 0.12 meter cube per second. So here we already find out what is Q through a 30 centimeter pipe. So this is 30 centimeter, 0.3 meter pipe. So D1 is equal to 0.3 meter. The pipe diameter is then reduced to 15 cm. So D2 is equal to 0.15 meter. Through a reducer, the pressure change across the reducer is measured by a mercury 13.6 manometers. This is mercury. It's not stated here, so I put it here. Okay. Determine the deflection H of the differential mercury manometer. This is once again a question of Bernoulli equation on this Venturi tube plus the study of manometer. And once again, manometer is used to find out delta P. We don't have this number here, so I just put a number 0.5 meter. Maybe while I'm copying this question, some of the number is gone. Alright, some of the numbers are gone. So I put it here again in this question. Okay, so we can do the same way as we did before from the last question. We prep our study by finding out what is the area for point 2 and point 1. So area for point 1 should be equal to pi 0.3 square over 4 . So 0.07069 meter square. A2 should be equal to pi 0.15 square over 4, and it is equal to 0.01767 meter square. Okay, so from there we have Q. So from Q we should be able to find A1 V1. So we can find what is V1. So V1 is equal to Q over A1. It is equal to Q 0.12 over A1, which is 0.07069. V1 should equal to 1.698 meter per second. And then for V2 equal to Q over A2, 0.12 divided by 0.01767. So 6.79 meter per second. That will be the number for velocity for point 2. Next, we do Bernoulli equation between point 1 and point 2. P1 plus Z1 plus V1 square over 2G equals to P2 plus Z2 plus V2 square over 2G. Okay, so Z1 and Z2, alright, we can see what we can cancel out from here. Nothing from this side can be cancelled out except for point 1. We have Z1 because this is the bottom part of the elevation. We use this as a reference, so we assume Z1 is equal to 0. So Z1 over here is equal to 0. For point 2, we don't have anything to cancel out. Again, we rearrange it so that we will get the answer in terms of P1 and P2. So P1 minus P2 is equal to Z2 plus V2 square minus V1 square divided by 2G, and then everything over here is multiplied by rho G. So equals to Z2 0.5 plus V2 6.79 square minus 1.698 square divided by 2 times 9.81. Everything is multiplied by water, and since there is no density for water there, we assume it's to be 1000 times 9.81. P1 minus P2 should equal to 26515.45. So 26515.45 Pascal. That will be for P1 minus P2. Okay, so we continue with the next slide. From before, P1 minus P2 is equal to 26515. 26515.45 Pascal. Okay. From there, we continue with the calculation for manometer. Alright, going from 1 to 2, this is 0.5 meter. So we go P2 is equal to P1, and then P1 is here, the next point is here, so it's a plus rho water G X plus H, alright, up until here, and then this is mercury minus rho Hg, mercury G H, and minus from here to here will be rho water G X plus 0.5 meter. X plus 0.5 meter. This is X. This is 0.5 meter. Okay, so is there anything that we can cancel out? Here we have rho Wg X plus H. So this X is positive. This X is negative. If we check on these two. So we can cancel out X for both sides. And then we can do P2 minus P1 is equal to rho W G. We combine. This is positive H. This is minus 0.5. So minus 0.5 minus rho Hg G H. So P2 minus P1 is equal to 1000 multiplied by 9.81 multiplied by H minus 0.5 minus 13,600 times 9.81 times H. You will get 9810H minus 4905 and then minus 133416 H. This is for P2 minus P1. So comparing the question from Bernoulli equation, the number over here. So the number over here is in positive mode. Okay. If we change it into, so let me do this. We finish this up first. 9810 minus 1. Negative 123,606 minus 4905. To make it the same as P1 minus P2, so P1 minus P2, we change the sign to be 123,606 plus, or this should be H here, plus 4905. So we compare both question or both numbers. So we'll get 26515 equals to 3606H plus 4905. So H will be equal to 0.1748 meter. So this will be the answer for this question. Once again, it's the same question as before, except for this is vertical and before this it's horizontal. Okay, this will be the last question for today. And this question is based on Bernoulli equation, and water is being delivered from a tank through a 150 millimeter constant diameter piping system. This one should be 100 millimeter. The water is discharged to the atmosphere through a nozzle with a diameter of 50 millimeter. So 50 millimeter. Determine the volume flow rate for water as it discharges from the nozzle into the atmosphere and the pressure at point A. So the question asks us what is the volume flow rate of water as it discharges from the nozzle here. So this is the nozzle. So we want to know the Q, okay, and the pressure at point A. So pressure at point A. So the question asks us what is PA and Q. Okay, first of all, since we have this question, we have nozzle over here, we have pressure at point A, and then we have a liquid tank with an open surface. So we may as well label each one of them. Okay, so here, this surface we label as S. So PS, pressure of the surface, should be equal to 0 because this is study of chapter 3. Chapter 3 is all about gauge pressure. If we meet atmosphere, pressure should be equal to 0. Velocity at this point should also be becoming 0 because this is at the surface of a tank. If you have a surface of a tank or reservoir that is open to surface like this, PS equals to 0. Vs will also be equal to 0. And next we have Zs. Zs over here, we assume this is the reference point. So elevation over here is equal to 2.4 plus 3.6. Zs is equal to 6 meter. Okay, here this is point A, okay, and this is point Q. So we can check on point A, PA is the one we are searching for. ZA, if you can see from this question, this is the reference point. So ZA equals to Z, the nozzle over here should equal to 0. So equal to 0 here. And then VA should be calculated in the question. Next, we have N, the nozzle over here. So Pn, since the liquid is moving out from the system, meeting atmosphere, equals to 0. Zn is equal to 0 based on this. And then Vn is calculated in the question. What else do we need to know? Okay, so we have 3 points, S, N, and also A. So we will play around with Bernoulli equation with these 3 points. We don't have any manometer, so this is purely on Bernoulli equation. And once again, I need you guys to remember the Q over here, the Q inside this, and the Q inside the nozzle, even though it is at the outlet of the nozzle, should be the same with each other. So Q at point A should equal to Q at point nozzle. So we can just put it as Q. Alright. What is the Q for S over here? The Q should be 0 because the velocity over here is equal to 0. To do this, first we need to find out what is the Q, and we need to find out the least amount of unknowns for the equation. So here we have 2 unknowns for point A. We cannot use point A for the first Bernoulli. We use point S and we use point N. Right? Okay, so before that we do and find out A. So AA is equal to pi times 0.15 square over 4 should equal to 0.01767 meter square. Then A N is equal to equals to pi times 0.05 square for 1.963 times 10 to the power of negative 3 meter square. Right. And then we can do the Bernoulli equation. First, we have S and N. Alright. So PS plus ZS plus VS square equals to PN plus Zn plus Vn square over 2G. So PS is cancelled out, 0. Vs is 0. Pn is 0. Zn is 0. So we want to find out Vn. Vn is over 2G is equal to Zs. So to find out Vn, Vn equals to 2. Okay, 2 times G times Zs, and then square root of it. So this is equal to 2 times 9.81 times 6, the square root of it. Vn should equal to 10.85 meter per second. Alright, so to find out Q for the question, Q is equal to AN Vn, so equal to times Vn 10.85. The Q should equal to 0.0213 meter cube per second. So this is the answer for the first question. For Q, it's the same as the answer provided. Alright, next we have to find out the V. So we search for VA first before we continue with the Bernoulli equation. So VA should equal to Q divided by AA. So 0.0213 divided by 0.01767. VA should equal to 1.205 meter per second. Okay, so we already have VA. Next, we do calculation for Bernoulli equation in terms of point A and also point N or point S. So I prefer point S. So between S and A, the Bernoulli equation will be okay, we can cancel out VS, 0. VS is 0. ZA, we learned about the reference point just now. It's also 0. We need to find out what is PA. So we will end up with this equation. ZS is equal to PA over rho G plus VA square over 2G. Alright, so if you rearrange the equation, it will become PA is equal to ZS minus VA square over 2G multiplied by rho G. So equals to ZS should be 6 meter minus VA just now 1.205 meter per second. Okay, and then multiply by density of water 1000, then the speed of acceleration of gravity. So we will get PA should be equal to 58,133.99 Pascal. So this will be the answer for this question. Okay, well, I guess that's about it for today. Hopefully you'll get the understanding on calculating few questions on Bernoulli equation. As I said to you before, the Bernoulli equation is the same, comparing between 2 points. However, the type of question will base on the application that we are going for. So we have to do a lot of tutorials, or we have to do a lot of final exams from before, so that you will see multiple type of application available, and by that way you can be able to calculate any questions regarding Bernoulli equation. Okay, that's it for today. Thank you very much. See you in the next class.